Hi, everyone. Thank you for joining us today for the session. I'm Kavneesh, and I run the APJ side of things for the Elastic community. So welcome, everyone. And we are hoping this is the first part of the session, and you'll be joining us for the second part, which is on the 20th, and then the third part of the session, which is on the 27th of this month. If you have any questions or if anybody's struggling to find a link or can't hear, please let me know and I'll help with the troubleshooting. Thank you again for coming and joining us today. Just a bit of an introduction for our community. We have about 142 user groups worldwide. We introduce other programs as well for our users. Our Slack workplace where you can chat with us. These videos and other videos for you to learn will be uploaded on YouTube. Our APJ virtual user group is right there. You actually join use your phone to scan that. And yes, you can have technical discussions about our products on our Discuss forum, where our community members, as well as our internal employees, people like our subject matter expert, Mohammed, he will actually answer all your questions and help you through the process. Our very fantastic and new addition is the Elastic Contributor Program. So as and when you make contributions to the code, if you're keen on presenting, you can actually add up points and win prizes like a free yearly training subscription with us, as well as things like swag, our great t-shirts, caps, and so on. So please feel free to connect with us. You can also send me an email at meetups.com and we can connect and help you present at the next session if you'd like. Last one important note is we are also hiring. We are hiring for the following positions. So please, if you're keen on it, you can apply at our careers link at elastic.co. All you need to do is scroll at the bottom and you'll be able to see the careers options there. If you have any questions, you can also connect with our HR. You'll be able to find the details there. And of course, there's a small link there for our cloud trials, which is valid for 30 days. And if you need an extension, you can always get in touch with our technical team. And over to Mohammed now. I hope you enjoyed the session and join us for the next one soon. Thank you.
Thank you, Kavneesh, for that. And hi, everyone again. For those of you who have just joined, my name is Mohammed, and I am part of the APJ team at Elastic, and I'm an education and consulting architect usually based in Melbourne, Australia, but I keep traveling here and there within APJ region. So today we're going to talk about data management with Elastic. And before we get started with data management with Elastic, a few assumptions I'm going to make here, although I'm going to try to keep the use of technical jargon as low as possible. But still, I assume that you at least know what is Elasticsearch. You have heard the name of Elasticsearch. And the best would be if you have some experience, you have worked with Elasticsearch before, or at least you have, if not worked, you at least know the basic terminology behind Elasticsearch, like what is an index, what is a cluster, what is a node, and how does those nodes form a cluster, and then what is the indexing process, what is the searching process. If you are not familiar with that, you are encouraged to ask the questions. That's not a problem. So we'll answer the questions as we go along. All right, so getting started, it's about data. Data is everywhere, right? We have plethora of data getting published every day, and it's growing, right? It's growing at the scale of petabytes every other day, right? It's the data that is getting published all over around us. It's not of the same type. It is of different type of data. Sometimes this data is in form of, transactional data, such as coming from the e-commerce websites, right? Other times, this data is coming from the applications and the servers and the logs that they generate, or the firewalls, for example, which are generating security events, for example, right? So in that instance, it's time series logs data. Another type of data could possibly be when you're collecting, for example, resource metrics in your infrastructure resourcing metrics. In that case, the data will be, oops, sorry, I moved too fast. That data will be called time series metrics data. So depending upon the type of data that you have, you're going to then apply a different kind of data management strategy. If you are an organization who is generating a lot of data, and you are trying to make use of that data to leverage that data to make, better decision making maybe, or being a profitable business maybe, you can apply, you can basically choose a strategy that goes on with the type of data that you have. So static data, for example, it sometimes it grows very slowly, right? For example, if you have a catalog of items and you're selling it on the e-commerce website, that catalog of item is not going to get, you're not going to add new 10,000 new products every day, right? Maybe you're adding few of those products, but not a lot of products every day. So that catalog itself is not gonna increase by size too much on everyday basis, right? Updates may happen very frequently, right? The older data, there is no concept of data getting old, because even after an year or 2 years, if your catalog is there, that's what the user is searching, right? So your catalog has to be there, and that's it basically, right? It seldom gets old. On the other hand, when you delve into time series types of data, right, that's the second type of data, static versus or semi-static versus the time series. And then within time series, you can have different kinds of flavors like metrics and logs. So time series data, the biggest property is it grows with respect to time very, very fast. And sometimes it's very unpredictable as well, right? Most of the time, updates do not happen on this type of data. An event that has been generated once, that's set in stone. That never changes. Very, very seldomly that gets updated. But more than often, it never happens, right? And the other property is this type of data, the time series type of data, when it gets old, right, it loses its value, right? It starts losing its value. And the older it gets, the more infrequent it gets used, basically. It gets accessed less frequently. So then, depending upon the type of data, we're going to make, we're going to create a strategy for data management within our Elasticsearch clusters, right? All right, so starting from really basics. So you start onboarding your data. And where does the data go? Data goes into an index in Elasticsearch, right? And as you keep on adding more data, onboarding more data, or ingesting more data, or indexing more data, all the same. It's just a different terminology, different words used for the same concept, which is adding more data to your Elasticsearch indexes. So once you start indexing or adding more data to your indexes, your index sizes start scaling, right? And there comes a point when your index is going to be so big that it may not fit onto your infrastructure, right? Your hard disk, maybe it's going to grow out of your hard disk, right? Maybe if you have allocated network storage, it's going to get too big that it's going to be difficult to even search within that index, right? So then what do we do? Within Elasticsearch, when we create an index, that index is backed up by shards, right? And there are two types of shards, primary shards and replica shards. So data sharding is happening in Elasticsearch from the get-go, right? And when we want to manage the data within our index, because the data is actually going to go on shards. So the more number of shards we have, the more data we have, we can span that. We can basically plan for adding that many number of shards ahead of time. But even then, those shards are part of that same index, right? You can physically go up to a certain extent, right? If you want to grow out of that context, go beyond that that certain threshold, then you're going to have to either keep adding more shards, right? Which is not ideal, right? And it has other side effects as well. But another useful way is to just create another index, right? And creating that other index has the same effect because that new index is going to have a set of shards associated with it. So in fact, you are adding more shards. But instead of updating the shards of the existing index, you have created a new index with a set of shards, and now you start writing to that new index, right? So you get more shards. That's what you wanted. You have scaled your indexes, and you are happy writing more data onto your indexes, onto your Elasticsearch clusters, right? All right, but then there's gonna come a point when this second index is gonna get too full, right? And then you're gonna need a third index and a fourth index and the fifth index, right? When you're moving between these indexes, the next challenge is you have a client application that's sending data to this particular index, right? So in case, the index name is my index 001 or my index 1, right? So my index 1 is the target index of this client application where the data is being sent to, right? When it gets full, right, to whatever threshold we say it's full. So when it gets full, we create a new index, right? And now it's my index 2. So now we're going to have to go back, update the client application, right? And that client application is, after update, it's going to start sending data to my index 2. So we're going to have to change the configuration in our client application, right? Instead of sending data to my index 1, now the client application is going to send data to my index 2. And this is going to keep happening. When you move on to my index 3, the client has to update. When you move to my index 4, the client will update. So this update of the client is going to keep happening, right? And that's a major side effect, right? All right. So how do we deal with that? The solution is we use index aliases, right? Now, as the name suggests, an alias is just a pointer, just a name given to a set of indices, right? So instead of referring to our indexes, index concrete names like my index 1 and my index 2, we create an alias, which is a pointer to the index. And we say that my index, which is the name of the alias, is pointing to my index 1 and my index 2. And my client application is going to use the name of this pointer, this alias, instead of using the concrete name of the index. Now, internally, what happens is when we create an index, we create an index alias, and then we assign that index alias. We assign the index alias to the particular index, and then we publish the name of the alias instead of the name of the index for the clients, right? So the client application now uses the alias name instead of the concrete index name, and that way we have kind of created an abstraction, right? All right, so now client application can write peacefully without knowing that we are creating new indexes, because whenever we create a new index, we just move our alias pointer to point to that new index for writing purposes, right? So that change is manual. It's seamless to the client though, right? On the read side, when we are getting data, right, out, for example, searching, right? Vishnu, I see you have raised a hand. I'm going to come to you just in a moment when let me complete this search part, and I'm going to come to you. Alternatively, you can type your question if you have a question or a need, and the team is there to help you out with the question and answer. But if you want to talk, just bear with me for a second, and I will come to you. When it comes to searching, so we have created a number of indexes, and the only difference between those number of indexes is that they have chunks of data, but that data is basically, in a larger context, is the same data set, right? That for manageability concerns, we have divided it into those parts or multiple indexes, right? So we would want to have search executed on all of those indexes at the same time, right? Writing of data or data ingestion may be happening on one index only, but the read should happen all the indexes, because it's part of all those indexes are part of one big data set, right? Okay, so then it is a property of index alias that your client applications can use the alias name to access all the indexes that this alias is pointing to for read purposes, right? Now, here is one hard rule there as well. You can use the alias to read all the indexes, right? Your client application can use the alias name to access all the indexes that it's pointing to, but for writing purposes, an alias can point to only one index, right? For read purposes, it can access all the indexes that it points to, but for write purposes, it can point to only one index for where it's going to write, right? And we're going to tell it which index to write to and which indexes to read from, right? All right, so let's get to it and let's see how does that happen. So to create an alias, we're going to make a post request, post HTTP request, and we're going to send this request to the _aliases endpoint of the Elasticsearch API, and within the body of the request, within the payload of this post request, we're going to specify actions array, and this actions array is going to take two actions. There are just two actions: add and remove, right? Here in this example, you're seeing just the add, but the remove action is part of there as well. So that if you want to remove an alias, from an index, you can use that remove action as well. So the first add action here is basically adding an alias on the index, and in fact, it's an index pattern. And remember, an index pattern is pointing to multiple indexes that match with that. Whose name matches with the name of the pattern that is mentioned in the index property. So here it says my_logs _ or my logs *, which means all the indexes that whose name is prefixed or starts with my logs, they're going to be part of this action. So the alias is my logs, right? So this my logs alias is going to point to all those indexes whose name starts with my logs, right? And this alias is for read purposes, right? Now, when we want to add an alias for write purposes, then we use the isWriteIndex property, right? And we use the isWriteIndex property and set it to true. And remember what I said during the last slide, that you can associate multiple indexes for read purposes to the alias, but you can only associate one index for write purposes, right? So then when you are associating the write index, you specify just one index name. Instead of index pattern, you specify just one index, one concrete index name. And in this instance, the name is mylogs 2021-07, right? You specify your alias name, and then you make it a write index by setting the isWriteIndex property to true, right? All right, so that basically is how we keep rolling on and on and on and on, right? We can create more indexes, we can keep moving our aliases, and we have a rudimentary way of managing our data across multiple indices, right? We can keep adding more indexes with more number, which have basically more number of shards in them, and then that way we can keep going around our business, right? but then data gets old as well, and when it gets old, it starts to lose its value, right, over time, of course. um, and 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 if the data is and we have our cluster infrastructure, it does not consist of unlimited resources. Our cluster has limited resources as well. So that data, if it's sitting within the cluster, then we'll have to think of a strategy to optimize the usage of the resources that we have assigned to our cluster. And one of those optimizations could be that we can move, we can create a cluster with variable compute resources. We can have compute resources, for example, which are more powerful, compute units which are more powerful, that use SSDs for writing, because our data our ingestion rate is very, very high. On the other hand, if since we are talking about time series data, once the time series data has been written to the disk, the only thing that then remains is reading, searching on that data. For searching purposes, we don't need SSDs, for example, right? We can work with normal disks, right? So then we can have a set of compute units with normal disks, not SSDs, because SSDs are more, they're not cheap, but we can use cheap hardware to support searches. So then we might want to move that data that's growing old and move that from that expensive SSD to the normal disk, right? And that way we can increase the data density of our existing resources, right? More data can fit into those SSDs. We make room for the new data that's coming onto those SSDs, so that way we kind of keep shifting our data from the front of the cluster to the back nodes of the cluster, if you will. If you understand that kind of intuition or analogy. So if we want to do that kind of adopt that kind of approach to manage data, to manage the data that's growing old, then we can do so, right? We can create data tiers, right? And in fact, data tiers is the solution to manage the data that's getting older, right? Now, what's a data tier? So data tier is a collection of nodes within your cluster and that collection of nodes has a dedicated role assigned to it, right? Since we are talking about data management, the nodes that we're talking about are data nodes, and the role that we're going to assign is going to be about data management. It's going to be one of the data roles, right? The difference is that the different tiers, the different tiers of data with respect to these different tiers of nodes are with respect to the time aspect, or the what you can say, the time aspect of the data. So the fresh data comes onto the hot set of nodes. When the data gets a bit older, we move it on to the warm set of nodes. And when it gets more older, loses more value, gets less frequently searched, we move it even to cheaper nodes that are a set of cold nodes, and then to the frozen nodes. So then we have 5 types of data tiers, basically. The content node is the default. Content role is the default role that every new index that gets created has. That's where every node has this role, and if you do not assign a node a particular data role, like hot, warm, cold, or frozen, that's the role that this node is by default going to get, the content role, right? And then you can specify which tier you want to use with your particular indexes, right? And how do you do that, right? We're going to get into that just in a moment. Let's just first see the content tiers, and how do we leverage these data tiers to implement our hot, warm, cold architecture, hot, warm, cold, frozen architecture, the infamous hot, warm, cold frozen architecture for managing the data efficiently. So the hot tier, if I go back to this picture, the set of nodes that are in the hot tier, they are powerful workhorses, right? They have the fastest storage for writing data, for example, SSDs, right? The nodes that are the nodes that are in the warm tier, right? The warm tier nodes, again, going to the previous slide to show you, they are more than often dealing with read-only data, right? And the data is searched less often than when it was on the hot tier nodes. And then likewise, cold tier and the frozen tier, the need to search the data when it becomes less frequent, right? Then we move it to cold tier, and then later on we move it to the frozen tier, right? All right. Just taking a pause to see the chat box. All right, so Vishnu has a question. All right, Vishnu, go ahead, ask your question.
One question.
Sure.
Can we manage this alias in the ingest pipeline? Like, can I say in the ingest pipeline, which is my write index, and can I automate this?
So the question is, can you use this alias inside your ingest pipeline? So ingest pipeline is the request that reaches ingest pipeline has already been fired, right? It's already been directed at an index, right? And which means it has already been directed using an index. So if you want to change at that point in time, that is not possible, right? You have already sent the request to an index, and it's going to that index. It's with the index, the request is with the ingest nodes, or if the ingest pipeline is set up inside the data node, then it's there, right? So the data is going to be the transformation that you have set up in your ingest pipeline, that's going to be made, and then the data is going to get indexed into the index that you have sent the request for.
Because I'll be using ILM for managing the index, like index 1, index 2, index 3, so that it happens automatically. But my client which is writing the data is unaware that which index is the current, which is in right index now, right?
I understand. So, okay. So the idea here is that ILM is going to automate the index rollover or the alias rollover, and we're going to go through the ILM just in a moment. And the whole purpose of having ILM there for you is to create that layer of abstraction so that you don't need to know the concrete index names, right? And in fact, we're going to go, we're going to cover in the I think in the part 2 or part 3, we're going to talk about even another layer of abstraction on top of aliases and on top of index names in the form of data. What's that name? So we're going to have that talk coming up as well. But yeah, the idea here is
streams.
Data
where
streams.
you're talking about data streams. Okay.
Thank you, Ankur. Yes, data streams. So the whole idea here is that you don't need to know the concrete index name for write purposes. The ILM is going to remove that need for you and automate that process for you, which we're going to talk about in just 2 minutes.
Okay, fine.
Okay. Another question we have is, do we have to specify content role to all nodes? No, Ankur, we do not have to specify that role to all nodes. Content role is the default role that every node has. Right, that's the default role that every node has.
Okay, so I face this problem. So I kind of marked a node as hot, one node I marked as warm, and one node I marked as cold. But it didn't actually work for some of the indexes. It said you need content node as well. So I faced this challenge, and I had to mark contentful with hot for my Kibana to work, and many other things were not even working.
I will need to see the configuration of the Elasticsearch.yaml to actually comment on this.
So I was working with operator, ECK operator.
Mhm.
And I kind of
Mhm.
configured the CR, and I added hot, warm, and cold configuration to the CR, and
Yeah.
my Kibana never fired up. So I had to went in and change the content. So my question is, do I have to keep a content node specifically, or let's say if I marked one as content, and then for frozen also we have to mark it as content for it to work. So this is one doubt I have.
No. So the whole idea is that the set of nodes that are frozen, they are not content nodes. They are frozen nodes, right? So the data tier
Okay.
is not content tier, it's frozen tier, right?
Okay.
And the set of nodes that are cold, their data tier is cold tier, not the content tier, right? So
Okay.
content tier is there if you are not dealing with, for example, time series data. But if you are dealing with time series data, then the best practice is to use that hot, warm, cold, frozen set of tiers for data management.
Okay, and I have another question around tiering. So let's say I have log data which I want to basically put in Elasticsearch. So hot tier, does it make sense to use hot tier at all, or we can use with some other tier as well? Because someone wants to query that data, we don't have to rewrite it at all, right? Once it is
Yes.
written, it is written.
So hot tier is the required tier out of all, right? All the other tiers are optional, but hot tier you cannot. It is not optional. It is a required tier. And anytime you create an ILM policy, the data by default gets written to hot tier, right? That's where it lands first. You cannot change that. The warm and the cold and the frozen tier, that's optional, and you can choose your data to be moved onto those tiers, those setup nodes from hot tier as you wish. But
and let's say if I've not defined a hot and I've defined content tier, then how this configuration will work?
So the data is going to arrive on the content tier nodes.
And if I want to put ILM policy and from content tier, I want to move it to, let's say, cold or frozen, will it work?
So if you are defined an ILM policy, that ILM policy will be assigned to set of indexes, and the indexes that this ILM policy will apply to, then the data will start arriving on the hot nodes because of the ILM policy. That's the required phase, the hot tier.
Okay, now I understood. Thank you.
Yeah, no problem. All right, so Hare Krishna has a question. I think only specific ones need to be given content role. Yes, so we had you heard the conversation I was having with Ankur, and that's correct. It's totally need dependent. Your need is going to drive which type of role you're going to assign to the nodes in your cluster, and that way you can manage that. All right, so these are some of the questions so far we have. If anybody has any more questions, please keep putting them in the chat box. That way I'll be navigating through the chat box more quickly, or I'll take pauses throughout the session and take your questions if you want to talk. All right, so moving on. So how do we then assign nodes within those data tiers? So the idea is all the nodes in your cluster have all the roles by default assigned to them, right? So, but if you want to have a dedicated role assigned to a node, a tier assigned to a node, then you're going to have to use the node.roles property. And this property you can make use of within the Elasticsearch.yaml file, and then you can use the node.roles property to specify what kind of role, a data role, data tier, for example, this particular node is going to have. So for example, in this example here, we are setting the node.roles property to data hot and data content, which means this particular node is part of both tiers, the content tier and the hot tier, and that way you can create a combination of nodes which are which could be part of multiple tiers, if you will. And then I talked about there are 5 types. There are 5 tiers, basically: the content, hot, warm, and cold, and frozen. And the configuration parameters for all these 5 tier types are data content, data hot, data warm, data cold, and data frozen. And you can assign these configuration parameters inside the node.roles property in the elasticsearch.yaml file. And remember, a node can have multiple tiers, be part of multiple tiers. So you can assign multiple configuration parameters to a node. And by default, all these tiers are implicitly assumed by all the nodes if you do not assign yourself. All right, and just a bit of more depth, adding more depth to this discussion. If you want, if you have created an index and you want this index to be placed on a certain tier, right? Then you can specify that at the time of index creation, right? You can do so in the settings of the index at the time of index creation, and then you can tell index routing allocation include tier preference, and then you can say your preference. For example, you want this particular index to be created on the hot tier nodes. So then you can say data_hot, and that way the new index logs 2021-03, that's going to get created on the on the data hot tier nodes. So up until this point, the discussion that we have done is we are doing everything manually, right? We are creating indexes, index aliases, moving those aliases. Then if the data is growing old, then we are managing that by moving the data to the less expensive nodes through the data tiering concept, and then we can place an index onto a tier ourselves as well. If we want to automate all of this, then the name of the solution is index lifecycle management, right? And index lifecycle management is gonna let you easily manage your data, which is in indexes, or if I say that it's going to let you easily manage your indexes according to your specific requirements. So you're going to specify what to do and when to do it, right? And this what to do and when to do it gets specified in forms of policies, lifecycle policies. And there are certain actions that are triggered during these lifecycle policies. Those actions are, for example, rolling over to a new index, which is creating a new index, and then pointing the alias automatically for write purposes to that index. And then, for example, if you are moving between tiers and you want to shrink the number of primary shards, then you're going to invoke the shrink action. Or if you want to, if you're moving between tiers and you want to merge the segments of a shard, right? Then you can use the force merge operation to optimize your read requests, your search requests. And then the freeze and the delete actions are there to help you save memory or permanently remove an index from the cluster as well. So all these lifecycle phases and actions and they are placed inside these policies, right? So if a lifecycle policy is broken down into 5 phases, right? The hot, warm, cold, frozen, and delete. These are the 5 phases. And within each phase, there are certain actions that can be taken. The actions that I showed you on the last slide, like rolling over, like freezing or deleting or shrinking or force merging, all of those actions can be taken within a certain phase. Not all phases have all the actions available to them, but you're going to know in a moment what actions are available within each phase. When we combine all of this into a document, that becomes a policy, right? And we can create and manage those policies from under one central management tool called Kibana. And if we go into the stack management under the data, if you see, that's a second option, index lifecycle policies, and you can go into the index lifecycle policies, and you're going to see the already existing policies. You can create a new policy by clicking the button there as well, and that way you're going to start the process of creating new index lifecycle policies. Now there are like I said, there are about 5 phases to a policy, and let's take a look at an example to drive through to work through this for creating an example policy, and hopefully that will help you understand the ILM process a bit better. So the first phase is the hot phase. The new data arrives in the hot phase. Even before we implement the ILM policy, and I walk you through this ILM policy example, your organizational policy for data management or data retention is gonna basically define how your ILM policy will be created and implemented and managed, right? So even before you create this ILM policy, you're gonna have to have a talk inside your organization with the stakeholders, all the stakeholders, and come up with data retention requirements. Those retention requirements may be use case dependent. Those retention requirements may be governmental legislation dependent as well, right? Sometimes governments can mandate you to keep the data in your cluster for X number of years, for example, or X number of months or weeks, depending on the type of data. So taking all things into consideration, then you're going to come up with your data retention requirements. And once you have those data retention requirements, then you can plan out how do you want to manage the data, seeing those data retention requirements. So for example, our requirement is that we're going to keep the fresh data onto the hot phase, onto the hot nodes for 2 weeks, and after 2 weeks we're gonna roll we're gonna roll over to the new index, and then we're gonna move that index over to the warm phase on the warm data tier nodes, right? And we're going to keep the data in the warm tier for 1 week, and then we're going to move that into the cold phase. And when moving into the cold phase, we want to freeze the index. We want to decrease the number of replicas because the data is being accessed less frequently, and we want to move to the cold storage, and want to stay in the cold storage for 3 weeks, basically, right? So 2 weeks in the hot phase, 1 week in the warm phase, 3 weeks in the cold phase, and after that, we're gonna delete the data. We're gonna delete those indexes for all those. We're gonna delete all those indexes which are 6 weeks older, right? So this whole data retention requirement then says my indexes are basically there for maybe 12 weeks in total length, right? 2 weeks in the hot phase, one in the warm, 3 in the cold, and 6 before they get deleted, right? So we're going to define an ILM policy for this requirement. Then let's see how do we define this ILM policy. All right, so 2 ways to work with ILM policies for creating these ILM policies. One is through the API, and the second is through the Kibana index lifecycle management interface. The easiest way is, of course, to use the interface. So when you click on the create new policy button, you're gonna have this intuitive wizard started, which is gonna take you through all those phases. So the first is the hot phase. And within the hot phase, you then define your requirement, how long you want the data to stay in the hot phase, and that basically is 2 weeks, so it's 14 days. So then the maximum age property we define that's where this 14 days requirement is going to go. And likewise, in the API example, within the policy phases hot actions, we're going to say rollover is going to happen at 14 days of age, right? So that completes our hot phase definition. Then we move on to the warm phase. And again, the most important thing here is we're going to say, when is data going to be placed into this phase? And we say zero days, or min age is 0 days, meaning immediately when the index rollover happens in the hot tier, move the rolled over index into the warm phase, right? That way we are freeing up space in the hot nodes or the hot tier immediately, right? So and then we have some advanced set of actions. Maybe we want to make the index read only, maybe we want to force merge the segments, maybe we want to shrink the number of primary indexes. All those actions will be available to under the advanced settings options. Then the third phase is cold phase. And the cold phase requirement is that we're going to move to the cold phase after 7 days after the rollover. So rollover happens, the data moves into the warm phase. We're going to keep it in the warm phase for 7 days, and then we're gonna move the data into the cold phase. So then we define the move data into phase property. Move data into phase when equals 7, or the min age equals 7 days. So the data is then gonna move over to the cold phase. Again, when we are in the cold phase, we have certain advanced settings available to us. For example, if we want to shrink the number of replicas, or if we want to freeze the index, then we have those options available to us as well. Once we have defined the cold phase, the next is to define the delete phase. If we want to delete the data after a certain amount of time. If not, we can keep the data forever on the cluster as well. So in this instance, we want the data to be deleted after 28 days. So then we say move data into phase when 28 days, or min age is 28 days, right? And after 28 days spending, after 28 days, this data is going to get deleted. So that then defines our complete policy. Once we have created this policy is sitting. Now we're going to associate this policy with our indexes, right? And there are a couple of ways. Either you can associate this policy with an index by directly going into the index management and then selecting the index and the invoking the manage index options, and then setting the and then adding the lifecycle policy to that index, or you can leverage index templates, for example, right? I'm not going to go into the detail of how to create those index templates and what are the different properties. I'm just going to show you a quick snippet here, which uses this index lifecycle management policies within those index templates. And if you know what index templates are, or if you don't know index templates are, they are just a way for defining your new index, defining a template for the settings and the mappings or the schema for the index. And anytime a new index gets created, if it matches, if the index pattern defined in index template, if the new index name matches that pattern, then this set of settings and mappings automatically get added to that new index. And indeed, when we specify the ILM policy inside index template, then whenever a new index gets created with the naming pattern that is defined in the index template, this new policy automatically gets added to or gets applied to this new index, right? So that way we can automate addition of lifecycle policies to the newly created indexes as well. So once we have applied this policy, now it's time to basically create our first index. When you are, and you can do this by going into the Kibana DevTools application, and then simply doing a put request, and then giving the name, giving an index name. When you give name to an index, remember to end the name with a hyphen and a number. That's a requirement because of the index lifecycle ILM policy requirement, right? Because it's going to do a rollover and it's going to automatically name your indexes. And if you have -1, for example, -2, -3, a number, hyphen and a number, it's going to be easier, or it's going to be possible for that ILM policy to create the new index with the same prefix name and just adding the next number to the number that you have specified. So when the next index gets created, that its name will be mylogs -00002, and the next one is mylogs 00003. So you give it the first name, and then ILM is going to give it the next names of the indexes. All right. So when we create the index, we associate. We create an alias. We associate this alias with the index, and we say it's a right alias, and then this alias gets used, and this is the same alias that we have defined in the ILM policy as well. So that way we are associating the alias with the ILM as well, and we are basically starting the automating process. And now we just sit back and relax. We start indexing using that alias name. Give that alias name to the client. It's going to start indexing, and your ILM policy is going to kick in. Whatever you have defined, all the interactions are going to go through this alias, and automatically when the time comes to create the new index, when it meets the hot phase requirements that we have defined, then new index is going to get created automatically. The rollover of alias for write purposes to the new index is going to happen automatically as well, and you are going to be a happy chap. Right. So that concludes our ILM discussion. If at any point in time you encounter any errors during during the application of your lifecycle index lifecycle policy, how do you troubleshoot it? Well, the first thing that you do is you check your index health. If the index health or the cluster health is not good, is not green, your ILM policy will not progress, right? The ILM policy will keep checking for the cluster health to come back to green every 10 minutes by default. You can increase that polling interval, right, by using the indices lifecycle poll interval property. Then the next thing is you got to check server logs, right? Logs are always your friend. They're going to tell you what went wrong and where it went wrong. And then you can, if you do not understand what is going wrong, you can show those logs. So for example, one of elasticians, right? And they can help you, or maybe some other expert, not an elastician, but an expert who can show you who can tell you what is going wrong. And then make sure you have the appropriate data migration strategy in place in terms of and applied in terms of data tiers, assigning the roles to the data to the nodes in your cluster. And then a couple of reminders, just to name your first index with a number, and a best practice is to use the index template and specify the name of the policy in that index template. You can get the detailed information about the ILM status at any point in time using the get the name of the alias and the _ILM/explain endpoint. Just a bit of couple of more points about beats and ILM. If you are using file beat, metric beat, winlog beat, packet beat, audit beat, any of those beats, then those beats use ILM policies by default to manage those rollovers, and their policies define that the data is always going to stay in the hot phase. They do not define the warm and the cold and the frozen state. If you want your data that is coming from those beats data shippers to be moved across multiple data tiers, then you're going to have to go and amend those policies or create new policies and apply to those tiers. So data never gets deleted. The new index gets created every 30 days or 50 gigabytes, whichever comes first, right? And you can of course use the beats to do that. And how do you assign data tiers within ILM policy? Within any phase, like warm phase, for example, you're going to have the data allocation property, and you can use that property to tell which set of nodes are we going to use? Which data tier nodes are we going to use, right? That's how you basically define, that's how you tell them, tell the ILM policy which set of nodes to use in which phase, right? All right, so that concludes my presentation, and I'm going to move to the chat and the QA to answer your questions. All right, so Thomas says, can ILM check the age from the last access to the index instead of the age from the rollover? And Mark has responded, no, it cannot do that. Thank you, Mark. Another question from Anchor is, for daily index, do we need to manually change index daily for writing? If you are, the whole point of ILM is that you do not need to do any manual changing of the indexes, right? And that's what we have covered so far, right? Hopefully by this time you know that you do not have to do any manual changes to the indexes for daily writing. You can specify the policy as such that would create daily indexes for you automatically, and you wouldn't need to worry about that. You just use the alias name for sending write requests and searches, both types of requests, searching and indexing requests, and everything will be done for you. Another question by Ankur is, do we need to apply content role to all nodes? I think we have talked about this already, so I'm just gonna mark done. And another question by Matt, do APM indexes have the same default ILM policies as the beats indexes? I am not 100% sure about the APM, but my hunch is yes. I will have to check on that. If anyone knows from the other panelists, maybe they can help me on that one. But specifically about APM, I think it's the same as with other beats. But specifically, about the APM, I have on top of my mind, I do not know at this time. Another question by Imran. Hi, what time did this meeting start? I had the calendar for 4 p.m. AWEST. Okay, this meeting started at 6 p.m. Sydney time, Sydney, Canberra, Melbourne time. But do not worry. Yeah, this meeting is recorded and it's going to be available to you on YouTube, right? It's going to get published, so you'll have the access to the content that we have covered anyway, right? So Mark has responded that ILM is enabled by default in APM, right? So the same policies that apply for beats are applied for the APM as well. Yes, that is correct. Thank you, Mark. Any more questions, comments? So we're gonna have our next talk. Let me get out of this view first.
This recording will be shared.
This recording will be saved, and this recording will be available and will be uploaded to YouTube, as Kavanish said at the start of the meeting. So this is the part 1 of the data management that we have talked about. There is the part 2 and part 3 happening next week on Wednesday, and then the week after on Wednesday, 20th October and 27th October respectively as well, where we're going to talk about data streams and searchable snapshots as well. So you are more than welcome to attend those sessions as well. Somebody raised a hand. There were talks about removing multipath in Elasticsearch for storage. Was there a reason for removing this option? Multipath with respect to, sorry, can you elaborate a bit more?
Muhammad, I think that means being able to provide multiple disk paths to Elasticsearch, and then it puts the data, the shards and whatnot, it creates onto multiple paths. If that's the case, that was removed because we just didn't really work in an ideal way. We were finding people were attaching disks of different sizes to the nodes, and so one disk would fill up and the other one wouldn't. People had a lot of different expectations about load balancing the shards across each of the mounts, which wasn't how it was designed. And ultimately, we found that rather than have Elasticsearch deal with that approach and figuring out where it stores the data other than just a mount point. The thought was, there's existing storage capabilities that can do that. So, you have specific hardware controllers. You can use LVM or different sorts of things there that really abstract that away from Elasticsearch and let it do its application stuff. And then you can handle the disk and the disk management on a separate layer, which is more suited for it.
Thanks, Mark. Thanks for that. Any other questions? Seems like we have reached towards the end of this talk. Thank you everyone for being part of this this meetup, and I would love to see you again. It was an interactive session and I enjoyed it. Hope you have liked it as well. And I would love to see you back in action next week and the week after as well, and to all the other meetups as well. Cheers. Thank you. Bye.